Hello, my name is Qiuyang Shen and my teammate is Yun Sun. Our project is about Xbox game recommendation. What we will do in our project is to predict which Xbox game a customer will be most interested in based on the Best Buy mobile website data. As Steve Jobs says, it's not the customer's job to know what they want. So having a better understanding of the customer's needs can help the sellers get more profits. We can see two examples in our real life. If we wanted to buy an algorithm book in the Amazon will recommend you the program language books like Java, Python, and C++. If you want to buy a tile in the Land's End, it will recommend you a shirt because many customers buy the two items together. The dataset we use is from the Cargo website. It can be downloaded from the following URL. It's about the query and click data of Xbox games among 1.2 million users on the Best Buy mobile website over 2 years. We will use 3 files in our project: trend.csv, test.csv, and smallproductdata.csv. In the trend.csv and test.csv, we have 6 columns. Each row will have those 6 attributes. The user means the user ID. SKU means the product ID that the user clicked. Category is the category the product belongs to. Query is the search terms the user entered. Click time is the product that was clicked on, and query time is the time the query was run. In the small product data.xml, we have all the information of our products, including the name, the category, the release time, and the descriptions. Before we run our methods, we will do some pre-process on our data, in particular on our queries. We first transform all the characters to lowercase and then tokenize these queries by splitting each query by space and hyphen, and then we split number and word. In this example, we see NBA 2K12 and NBA space 2K12. These two search terms, we treat them as the same. So after splitting the number and word, the search terms becomes identical. And then we do stemming. We transform various forms into a common form. In the right-hand example, we see connection, connections, connective, connected, connecting. All those words will be transformed into connect. In the last step, we check the spell. We use an unsupervised learning dynamic time warping technique, which is usually used in the time series. And after doing this, many of the misspelled words will be transformed into the correct form. In the following example, we can see the body field will be transformed into battlefield. This is the text cloud of our queries. It is based on the appear frequency of each query. The method we adopt is a hybrid recommendation method. There are 2 kinds of recommendation methods. The first one is content-based filtering. We calculate the similarity score based on the description of the product and the query, and then we extract the top 5 descriptions that has the highest similarity score with the query. The second kind of recommendation method is called collaborative filtering. We have 2 methods under this collaborative filtering. The first one is frequency-based model. We extract top 5 products for each query. And second one is multi-classification, SVC. We extract the most possible top 5 products based on the similar patterns of other customers. The final result is actually the combination of these 3 methods above. As we can see in the next slide, the final result performs better than each individual method. In order to analyze our results, we need to define the matrix of evaluation. We have 2 matrices. The first one is precision. It is the percentage of cases in which the real product is among the top 5 predictions. It doesn't matter the real product in the first place prediction or in the 5th place prediction. It all counted as successful. The second matrix is the score. The formula seems to be complicated, but it's actually very simple. If the real product matches the first place prediction, we gain 1 score. If the real product matches the second place prediction, we have 1/2, that's 0.5 score. If the third prediction matches the real product, we have 1/3, that's 0.33 score. And the final score is the average of the scores. Here is the result table. We can see the final combination performs better than each of these methods, no matter in precision or in score. And then I will show the demo of our project. The first thing I would like to show is our dataset. As I mentioned in the slides, the data can be downloaded from the Kaggle website. This website has a clear description of each data file, and we only use trend.csv, test.csv, and small product data.xml. Because the test.csv does not have the real product that customers click on, so only use the test.csv, we cannot evaluate our results, our methods. So we split the trend.csv into 2 parts, training part and the testing part. This is the original trend.csv. And we can see there are about 42,000 of rows. We randomly split the trend.csv into training part and testing part. And the splitted training part have 38,000 rows. And the testing part has about 4,000 training rows. So that's the dataset we use to train our method and test our method. In our query processing step, the transform, tokenize, and stemming, these methods are provided by the Python or other packages, so I will not show these methods. The split number and word is very simple and it's internal method, so I will not show them too. What I will show is the spell check method. A key observation of the spell check is the misspelled word usually miss 1 character or have an extra redundant character or have a wrong character in the corresponding place. So I transform all the characters into a time series and define a custom function. The function returns 1 if the 2 characters are not the same, It returns 0 if two characters are the same. And then I use dynamic time warping technique to extract those two words that have distance less than 2. And meanwhile, one word, the frequency of one word is 10 times of the frequency of another word. Then I consider the word with less frequency as the misspelled word, and the word with higher frequency is the correct word. The data structure I used for this spell check is a dict. The key of the dict is the misspelled word, and the value is the correct word. I'll show you how many words will be transformed and how they are be transformed. As we can see, these words are transformed into the correct form. So basically, you can see all the words look similar like Arkham will be transformed into Arkham, and assassin will be transformed into assassin. There are many words looks like battlefield will be transformed into battlefield, and so on and so forth. Then I will show you our recommendation method. Because this method takes a long time to run, so I will not show this how we run this method, but I'll show you the result of this method. Okay, I will run a result analysis program. We first see how the content-based filtering performs. Oh, sorry. The precision is about 0.6 and the score is around 0.38. Then I will show you the result of frequency method. The precision is around 0.85 and the score is around 0.73. Then I will show you the SVC method. The precision is around 0.89 and the score is around 0.75. So these are three individual methods. What I will do is to merge these three methods to see if we can have a better results. Okay, so after merging these three methods, the precision is now over 0.9 and score is around 0.77. So we can see the combination of three methods can achieve a better result. This is actually a good result because basically the true product is either in the first place prediction or in the second place prediction. Because in the first place prediction we gain 1 score, and in the second place prediction we gain 0.5 score. The reason of precision is around 0.9, but not nearly to 1 is I think is because some users will type some very general queries like Xbox, Kinect, game, those words, but what they really want is not very popular games. So for these queries, all of these three methods will not achieve the correct result. Okay, here's our demo. Thanks for watching.